Vivi Song is a director of data science in Roger Communications, so I'm going to give you this.
Okay, so this is for the slide, right?
There for slides, you can go up and down, and
So right means next page?
yes.
Okay. Okay, good afternoon, everyone. It's wonderful to see you all here. My name is Vivi Song, and I'm the director of data science from Rogers. I'm sure some of you in the room are Rogers customers. I lead our marketing data science team, and I've worked with Rogers data science team for over 11 years. Back in 2014, I joined as the first data scientist in Rogers with the title data scientist. And at the time, there was no formal blueprint, just a vision, curiosity, and the need to show how data could truly drive business impact. And since then, I've had the privilege of helping to shape how data science team evolve at Rogers from an individual role, data scientist, now a team leader. I'm able to manage end-to-end enterprise-level capability. Throughout my journey, I've worked just about many different parts of the business parts, including marketing, operations, digital, and even our credit risk strategies. And most importantly, I've spent a lot of time working closely with our business stakeholders, working closely with them, taking in model requests, translating business goals, as well as turn them into technical solutions, then presenting to our senior leadership to drive real adoption. Because many of you may know, building a great model is just one of the steps to get it really show the value, adopted, and being used in the business is where really the impact will lie. Whether you are here as someone who actually lead a data science team, or you are some business stakeholder who may work more closely with a data science team, or you're actually a data scientist working on building these models, I'm hoping you can take away some insights, which is practical back to work. Now let's get started. Okay, so I'm putting down 4 parts here because this is typically where my data science team will collaborate with different parts of the organization. We'll have business users who come to us to give a requirement, and our own data science team will develop the solution. And because we are supporting production level business usage. Like, for example, any marketing message you are receiving from Rogers for maybe add-a-line or cross-sell, upsell, those are all driven by a model behind. So it has to be delivered through IT production support. And finally, we need to work with the marketing and operations team to make sure the adoption of the model is all aligned for their strategy decision making. And I'm putting down multiple steps here. I'm going to go through one by one. Just from my view, this is not very clear. Give me 1 second. Let's see. I just want to have a better view of the presentation. Give me a sec. Where? Oh, sorry. Okay, thanks for reminding me that. Okay, so we have from model intake to data availability check, and then data scientists will do the model development, and we have IT support to do the model deployment and to enable model adoption. And finally, we will also monitor the model performance to make sure all the models are being monitored, so that in case there is any deterioration of the model performance, we'll be able to fix the model at very fast speed. So I'm going to go through each of these one by one in more details. Hopefully you can find some parts related to you. So the first part is we need to engage with business stakeholder to take in the requirement. And this step is really important to have an initial meeting with the key person, and usually it's a VP level or even a director level from the business side. They will tell us what kind of model they are requesting. And part of this, like the reason why this meeting is really important is we need to first understand why this model is required in the first place. We need to gather some context background to make sure the model they are asking for is the right model to build. Because sometimes the business stakeholders are not totally sure, or they do not know too much about what kind of machine learning model we are capable of building. So they have some ideas to say, hey, can you build a model to predict this and that? But as data scientists, it's really our responsibility to dig more, asking for more information, like how will this model be adopted after it's being built? So we basically will prepare a model intake form. We sit through a meeting, go over some of the most important questions. So I put down a few bullets here, as you can see. The first one is why this model is required and how the model will be built. I'm going to elaborate a little bit on here. So when I talk about how the model will be used, for example, if this will be a campaign behind, for example, if, let's just say, we're building an ad line model. For Rogers, you know, we have wireless and internet kind of business. That's part of the core products we support. And for a customer with a wireless account, let's say we want to promote a campaign to sell to the customer to add another line, that will be the requirement. But for data science team, we want to know how frequent will the campaign be sent, and how do they measure the success of the model by asking questions like, do you measure the campaign take-up rate in 7 days, 14 days, 30 days, or 45 or 90 days? Because those will be important for us to know how to optimize for the model building. Each of these may lead into a different model that we can help to build. And also, we'll be asking questions like, what kind of frequency do they run these models, or do they use the models? Some of the models may be used on daily operations because they will be doing call routing initiatives. Some of them will support the inbound call center. So obviously, this needs to be updated daily. But some of the campaigns, maybe they're weekly, bi-weekly, monthly, or even quarterly. So we really need to ensure how the model is being used aligns with what the model we are trying to build. On top of that, we want to understand that this is the top business priority because we are the most central data science team, and as I told everyone before, we support lots of business units. So there may be multiple requests coming at the same time, and we really have to prioritize to make sure we work on the most important things. And how we do that typically is we ask the business to do an estimate for the business value estimate. Nobody will hold against our head later to say, hey, you didn't build, like this business value estimate is 10% off or 20% off. However, this initial calculation will definitely put some logic to define so that we can bring in together, and when we have too many requests, we'll try to prioritize by talking to business leaders. We have different units. Like if there are 5 models from one business unit, then we try to talk to that business leader to see which one of these is top priority number 1, 2, 3, 4, 5, and we'll plan our capacity accordingly. Another question I asked, which is really important, is will this priority last? Like, is this strategy going to be ongoing for the remainder of the year, even for next year and upcoming time. Because sometimes the business requests may change so often, and even the business team priority, they may change themselves like month to month. For those kinds of situations, because it will take some cycles to build a model, to deploy the model, it may not be the best case scenario to submit a model request. Maybe it can be an analysis instead. Maybe it can be a one-time manual model building and providing some scores to share with them, instead of putting that into a model production pipeline. So we always check with the stakeholder to see, to ask for the priority sustainability, to make sure we are working on the models that are still needed by the time we finish building the model. And I put down an example of the model intake form, which reflects some of these questions. And by putting the request in formally with my team, we'll make sure when we do the planning, we typically do quarterly planning for the data science team, we'll have the same alignment with each of the stream leaders, so their models being asked aligns with the business leader has in mind. The next part, what we'll do is data availability. This may sound like too simple, but the reality is for data science team, we do not really have access to all data in the organization unless we ask for access for it. And in a lot of cases, if it's a brand new model, that we don't have today, then the data logic or the data itself even may not be readily available for our access. So once we take in the business requirement, we do have to evaluate, do we have enough data there to define the base that we work on? For example, if we only want to work on just to make a simple example, if we only want to work on internet customers, are we able to identify that customer base for the data scientist? And we also need to identify the target we try to predict. For example, if I want to predict which internet customer will churn in the next 30 days, then I need to at least be able to identify in my database who have churned from what date to which date. So things like this, we have to get the base and target definition. And most importantly, I put down the third bullet is the feature, which really goes into the model to make the prediction. And as a data scientist background, I must say that the data goes into the model plays the most important role, because we all know garbage in, garbage out. If I do not have all the signals that are required to make the prediction available, then my model performance typically wouldn't be good. For example, if factor X really predicts my churn likelihood, but I do not have this factor X data available to be used, then obviously my churn model, no matter how hard I try, how many other more data I put in there, this churn model would not work too well, because the most important data is not there available. And how do we define these features is typically we talk with the business, and they generally have some insights based on their operation knowledge. We also use our own hypothesis. The good thing about the telecom business is we are all users ourselves as well. Like, we each have an internet, we each have our wireless phone, we have TV, we basically have everything that we sell. And the way we do some of those hypotheses is we put on our customer hat as well. What do we think we will do when we shop around for internet, when we shop around for a new wireless phone or a new wireless plan, and we started to assemble some of the features like that. If we find some of the features are currently not available for a new model, then we need to talk with some other people to identify where is the data, and then we put in a request to make the data available for model building. And by the way, like when I was in the roundtable, I was sharing that for this data piece, we only work with production level data. This is very, very important because our model is production grade. We support the frontline, like call center, retail operations. We support the digital pages if they are changing the offers for the customers. So basically, I cannot afford when a data is sitting in some sandbox in a personal workspace, and let's say the data is changing in structure suddenly, and we are not informed. That will definitely break the model. So that's part of the main reason that we never work on any data which is not in production. Of course, we can work with those data not in production for exploration purposes and say, hey, we find this data is useful, but if you do want us to use in a model, please put it into production. And this is kind of related to the data ops part. So once we get all the data available, the data scientists will start to work in the model development process. And part of this, I'm breaking down into a few, let's say 3 key points I think will really drive our model performance when we build the model. The first part, I'm calling it the feature engineering. This is a part where we really design the data to have the input that we think will work to predict that for that model. And a lot of this, as I have mentioned earlier, it comes from our own hypothesis, and may come from the business. And sometimes it's also data science techniques. We know certain techniques may work for building certain types of model, and we may transform the data to use features like that. The next part I want to highlight is we may also do some explorations in advance. Let's say we have digital websites, because you can imagine for a telecom company, if you go to therogers.com, you can get into so many subpages, so many different websites, but which page is more related to customer may buying a phone, or which page is more related to customer will churn in the next little while. That requires some pre-data exploration to do the feature engineering so that we can put it into the model, because otherwise you may expect 50,000 features put into the model, and that usually is not very efficient. So we basically do the work in advance to filter the features which are most likely to end up in the model. We may even combine some of the features to make the model work better, to make those features to pop up in the model. I also put down a bullet point for meaningful inputs. Most of the inputs we design, when we think about it, to explain the model to the business, it should make some sense why that variable is there. First of all, we do not want something to be totally correlated with the target. So, for example, if we are trying to predict churn, you cannot have a variable to say the customer called to churn as an input, because that's already the target itself. And of course, putting that in will have a great model, but it's literally useless. So we basically want to put in features which can really help with the prediction in advance, and even help the business to create some of the programs. Like, for example, if we know certain web pages, the customer visit those, and then same day or next 7 days, 14 days, customers are more likely to churn, we'll create some kind of programs to help to have more offers available for those customers. And then the second point I put down is for training period selection. So what I have found is that depending on which period of history that you choose to train, that will make a difference in your model prediction power. The key is the model basically learn from the past. If the future, like basically the assumption is the future is somehow will repeat part of the behavior through the historical. If we think the future will change completely from the history, there's no point for building a model. However, if we're trying to learn from history, we need to identify a period where we think is more representative for the future. So whether you choose 1 month to train, or you choose half a year of data to train, or even 2 years data to train, this really depends on the problem itself. There's no one answer that fits all. But we do have many examples where selecting the right period of training make the model performance improve a lot. And the third one, I think this is basically a lot of the people who first started to train model, they will know there are different algorithms that they may use to train the model, and then eventually they need to pick one. But even within the same algorithm, let's say we do a gradient boosting model, it's possible that we build 10 gradient boosting model, and we just basically do hyperparameter tuning so that we have different model using the same algorithm. So sometimes I get questions from the business to say, hey, did you try different algorithm? And most likely the answer is we did, and and on top of that, we also tried different combinations of the same algorithm to see what works the best. Okay, next I'm going down to the model deployment piece. We have our own support. So whenever there is a model data scientists develop, we basically pass on our script through GitHub. We have what we call the ETL process. That's the code to extract for which customer is included in the model, what are the features required to be scoring for the model. That's the part we call ETL. We also have the scoring code itself, which takes the scoring data prepared from the first step, and we run through the Pico file generated for the training process so that we are able to generate an output. If I try to explain this in a more simple term, you can think of a model like a mathematical formula. Let's say we have something y equals to a plus bx. This is the most, I would say, the simplest equation I can put in for a mathematical equation. The x, you can represent the features we are trying to use to predict the target y. So our model is trying to define that what is the parameter A, and what is the parameter B is. Depending what's A and B, your equation will be different given the same x as an input for y. So that's basically in a nutshell what is a model. And we have a package that can take in hundreds of the model features and translate that into a model output. For us, if you think of a most easy example, the one that I mentioned, whether the customer will churn or not, this is a binary prediction. We want to know whether the customer will be more likely to churn in the next certain period. For example, 30 days or 7 days or 90 days, whatever the business required. And essentially, the equation we have for the model package is trying to calculate for all the customers, millions of customers, what is the probability of churn. It's going to be somewhere between 0 and 1. And we'll be able to rank all the customer probability from the highest to lowest, and we'll know which other customers are at risk the most. And this is basically a ranking game, and we basically target the people who are more at risk for churning, or we are targeting the customer who are more likely to buy something if we give them an offer. That's basically how they are using this model. And I have a snapshot there that shows, okay, this is part of the GitHub folder. that I can log into different models. It's only a small snapshot. I cannot show the whole thing. Next step I'm talking about is the model adoption. So this is a piece where I really need to, so after I do the intake at the very beginning, after the data scientist develop the model and the IT team help us to put in production, now I need to go back to the business to make sure they deliver on what they promised at the beginning when we do the intake meeting. They need to use the model. So this is what we call model adoption. So we go back and help them to redefine if they are going to use it in a campaign as they said earlier, how do they access to that model output, and which cutoff they need to choose. Do they work on top 1% of the customer based on the prediction? Do they work on top 10% of the predictions, or do they work on maybe top 40 or 30% of the predictions? Depending on how the model performance works and depending on the ROIs on some of the arbitrations, those decisions will be different. And typically, our models are going to be being adopted into two streams, what we call inbound versus outbound. Inbound means if the customer call into the call center, we will have different models to arbitrate what is the best offer the agent should be talking to the customer to. And for the outbound is really the text messages you may receive, the emails you may be receiving, to govern those messages so we don't irritate the customers too much, to give them the right offers, because we don't want to spam the customer as well. Technically speaking, we can send all the communications, all the offers to all the customers and sit and wait who takes which offer. But that's way too much because we have so many different offers. We really want to send the right offer to the right customer at the right time. And these 6 steps, I'm really putting together, very proud of this, because many companies I talk to or many of the consultants I work with, they have clients who work with other data science teams and they do not really have such capability. So what I'm putting here is we basically constantly monitoring our model performance. We currently do it at a weekly and monthly basis, but we also have a capability to do this on a daily basis when we need to. What it means is I can technically monitor every week how the churn model is capturing the churn from the previous week. And that's really powerful because if there's something wrong with the input data, let's say one of the data did not update and cause a drop in the model performance, we'll be able to catch that early in advance. We don't wait until 3 months to find out that the model has failed 3 months ago. Because most of the time, the business just trusts the model is working, and they are using the model, and we are here at the back to ensure the model is living up to expectation. In case we see drop, we identify the reason. Maybe there's a data that didn't refresh, and we talk to IT to fix that, or there's some other reasons. Let's say if there is a real shift, let's say there's a competitor force for some reason that comes in, we may need a new model, then we need to raise that and initiate the project. On top of that, we also monitor the inputs itself. We basically call that data drift. We try to see the most important features for every model. How does that feature have changing pattern or changing trend over time? If it has been deviating too much from the time we train the model and model performance drop as an observation, we may know that it's time to retrain the model because certain customer distribution have changed and the model may no longer reflect at the time of training. And the bottom line chart really shows you one of the snapshots I took. Like we are monitoring the weekly performance of one of the models, and you can see typically the model performance is pretty stable and is performing pretty well. And you can also see a dashed line at the bottom. That's a straight line, which we set as a threshold to say if the model falls below that threshold, we really need to retrain the model. We'll take it back. Okay, that's all for me. Thank you.